to keep the graph density low is working with trend signals. As you see, originally our dataset had mostly very high correlations between each sensor, and we thought that that was an issue related to the presence of an underlying trend that is linked to the production regimes of the system analyzed. In fact, by working with different series, so different series, we were able to clean out those spurious correlations that, of course, exist without caused by the presence of underlying trends, but which are not true in general. So we see by working with different series, we had correlations only between those intuitively correlated signals, because we were able to focus really on those relationships that exist between our data. So speaking of the data model involved, we resort to a so-called reconstruction-based approach in which we train a model to compress and then reconstruct the original signal. In this case, we are working in a graph domain, so we are trying to encode and reconstruct the original graphs or subgraphs in a way that is good, that is adequate. And for doing so, we resort to a very well-known neural architecture for these tasks, which is the autoencoder. Specifically, we adopt an improved, enhanced version of the original encoder, that is the variation of encoder, which in this case maps each node to the parameters of a prior distribution of choice. We selected the Gaussian because one of the most simple and popular also. And then the actual latent vector is sampled randomly from the identified distribution. So this also introduces some noise for the decoder to stimulate its generalization ability. Basically, this is known as the reparameterization trick. General idea is to have a little space that is as continuous and regular as possible. We observed, however, that this architecture was not actually enough to do so. So we embedded our backbone model into an adversarial framework um, to try to better enforce the continuity and the variety of the latent space. We couple each component of the backbone model to a discriminator or a critic, one for the encoder, the regularizing discriminator, which judges or says the realness basically of the label embedding by comparing those with two samples from the prior distribution, and a graph discriminator which basically is trained is involved in the training by judging the realness of the reconstructed graph. Moreover, the cycle consistency loss is also applied to the encoder, which should reproduce or reconstruct the graph as a whole in a way that is good, it is realistic, basically. So in general, our model uses GNN modules, and at the end, it is able to generate a critic score and reconstructed attribute for each node and each edge in the input graph, basically. So we basically come out with three different sources of anomaly score. The general approach was trying to combine those scores into a single one, and we will see how basically this combination is, of course, fine-tuned previously on the training set. So the general approach is this one. We train our model on signals or graphs that were labeled as normal grading conditions once, And then we store the entire training set containing anomalies, and we use those labels to fine-tune both the combination strategy and a threshold. So on the training set, as you can see, we perform a very extensive research involving the weight of the combination. In this case, we use a convex additive combination, but we tested more of these. And of course, a threshold for our scores. Now I will introduce you to a case study. This is one of the industrial machinery that we had the opportunity to work on. It is a gas turbine generator that is currently deployed at an extraction plant in south of Italy, and it is dedicated to self-generating electricity to provide the entire plant. So we had measurement on the turbine operating conditions, we had several temperature and pressure measurements, also vibration levels, and of course electrical ones, so the amperage voltage and frequency of the output of this very important machine. So these are the scores that we obtain on the training set. As you can see, more or less within the confirmed anomalous intervals, our scores are on a higher level. So not all the scores exceed our defined threshold. That's because this is also a challenge related to the labels we had and also to the peculiarity of working with different data. So we have a model that can identify anomalous variations rather than anomalous operating conditions, basically. As you can see, we have also spikes right before and after systems switch off. So the model is able to also detect system regulations or the operational procedures that precede a shutdown. So one of the things that we have done is also grouping the individual anomalous variations, point anomalies that our model detects, into contextually defined ones. So by allowing a gap of, say, 12 hours, we group individual point anomalies into delimited intervals for comparability with the labels that we have at disposal. These are the results on the test set. As you can see, by applying the threshold that we had previously defined, our model is able to repeatedly detect and flag variations and anomalies within the confirmed 7 days anomalous interval. After applying the aggregation logic that I was mentioning, we obtain that our model detects the longest contextually defined anomaly as the longest one, basically, with fewer false positives that are mostly short-lived, basically. What we have done is also comparing our scores with the production model that is currently deployed by the firm that partners in the project. They employ basically another reconstruction-based method. Um, Basically, their model has provided better coverage of the anomalous interval, but also it has some longer and more frequent false positive, which may cause unnecessary alert to the operators. They define also a volume threshold, which we were forced to use while we refer to our alert one. Anomalies that our model identifies. These are our scores with proper performance measures. We have a better precision overall, while the production-based model has better coverage, thus leading to an higher F1 score, basically. We also benchmark with a more traditional approach, following the same proposal that we followed, and this we observe lower performance basically. One of the advantages of our model is the possibility to interpret the overall scores. Basically, we are able to identify and analyze from a fine grained point of view the observation that we are involved and cause the anomaly. We can split the graph data that we provided the input to model to identify which nodes and edges were responsible for that prediction, for that detection. So this allows for better greater opportunity of model interpretation and also root cause diagnosis from the operational point of view. So few conclusions. We found that our model is capable of detecting those the anomalies that we were provided. Also, its fine-grained possibility to analyze scores may be of help when treating the sensors as ensemble of detectors, but we are currently working on using more adequate GNN modules and also working on different alternative graph mapping algorithms. So thank you for your attention, and I'll wait for your answers.
Thank you, Giovanni. Congrats for this topic. Any question? Actually, I have one for you. The possibility to extend the method to other, let's say, structure, other, let's say, field also of interest. Is there any possibility? Or
Yes.
Please.
Yes, we have already run the model on signals from a data center. So on the mechanical and electrical system of a data center. So about 70 signals from the data center of our research institution. And we have found that the detection performance is also good, also in unsupervised settings, which we don't really have confirmed anomalous periods. So the model is robust enough to be trained and also detect those anomalies on which it was trained. So it's robust and gave us some interesting insight on graph data, on signals, potential anomalies.
Thank you. Really, really nice. Thank you again. Thanks, Giovanni. Then I invite here the second speaker from for the today, which is Arnaldo, right?
Yes.
Fantastic. So let me prepare for you.
Which is the mic? I don't know if the person's
Over there.
Okay.
So before I have to.
Okay, we have a special attendee. It is not registered in the conference, but I hope you have a question.
Wait a second, because here I have some. Oh. Share. Let's try if it works.
Okay.
Should, without any problem.
Yeah, it works.
It
But
works.
what's the only thing is possible? Can I move slightly the computer here because I prefer to.
I prefer no.
Okay.
I prefer to not move.
Okay. Okay.
That's it.
Because
Okay.
I prefer to have the computer on my front, but okay, understand.
Okay. Please go. Okay, here.
Okay.
So let's give me the floor to you, and that you will say, bring us through the understanding of the signal feature impact in CNN-based modulation classification with the realistic data set. Please, the floor is yours. 20 minutes as well, Linton.
Okay, thank you for the introduction. So my name is Ronaldo Oliveira. I come from the University of Aveiro and from the Communications Institute, also in Aveiro. I'm a professor and a researcher. So this is the outline of my presentation. I will provide an overview of the path we are doing towards 6G communication systems, just an overview. Then, to understand the remaining of presentation, I'll also give some insights about RF frequency basics and impairments of the systems. Then I'll move to RF limited modulation classification, why it is important in the scope of 6G systems and what we are doing. Then finally, I will move to the work objectives and motivation. I'll provide how the information about how the data set was generated, what is our laboratorial setup, some preliminary results, and also the final remarks. So, first of all, 5G is deployed. The research community is currently working on 6G. Why? Because there are new applications that are emerging, new use cases, each time more challenging. The user requirements are also becoming more stringent, so we need to work on this next generation. Then, in fact, here is a timeline that shows how the communications generations evolved over time, and we are currently here, so working on this next generation. So this is the vision, possible vision for a 6G enabled society. We want to have increasingly rich experiences. 6G will continue to provide support for different ICT services that, on the other hand, will also enable many applications that we use in our daily life. Some of them will be improved with 6G. Some also will be new. And we hope that 6G will also contribute to achieve the sustainable development goals of the United Nations. So, in fact, we will have a society that is increasingly connected. So, just to make a comparison of what is 5G and 6G, in green we have the requirements of 5G. On, I would say, orange, we have the requirements of 6G. And we know that we want basically everything. We want more user experience at a rate. We want higher peak rates. We have more traffic capacity per time per square kilometer. We want systems, our mobile phones, our computers be more energy efficient. We have much more devices per square kilometer. We want lower latencies, for instance, to enabling autonomous mobility, autonomous driving, for instance. We want to provide transport platforms that will move faster, and very important, and is mentioned in all conferences, that we want to use spectrum more efficient. As you probably know, for support of communication systems, use electromagnetic spectrum, use radio frequency signals, but in some bands that are more interested from this perspective, spectrum is very crowded. There are lots of services, and we want to use spectrum more efficient. We want to use more bits using less bandwidth. So, in summary, these are the challenges. We need to move to higher frequency bands to have wider bandwidths, reduce latency, and use spectrum more efficient. And this is a snapshot of the electromagnetic spectrum. And as you can see, in a relatively small band, we have lots of services, and things are becoming even more crowded. Just to provide an overview, because then I will talk about the modulation and identification, and it's important to even briefly explain what is modulation in a communication system, in a telecommunication system. So, typically, we have on communication system a transmitter and a receiver. On transmitter, we want to take bits, we want to put them on air. On receiver side, we want to do the opposite. These are the main steps. We take the bits, we perform a modulation step that is basically take the bits and represent them as a complex number. In mathematical terms, it's just this. Then this generates a waveform at a low frequency. Then in order to adapt this waveform to be radiated using the antenna, we have to raise the frequency. We have to move to a higher frequency. So this is basically done multiplying the baseband waveform at a lower frequency by a sine or cosine wave. It basically moves the frequency, the signal to a higher frequency, and then it can be propagated. Of course, this is not ideal. There are impairments, there are imperfections. On the receiver side, the opposite operations are performed, and again, there are also impairments, there are imperfections on the systems, and those imperfections are responsible for most of the processing in telecommunication systems. So, but the idea is the modulation. Take bits and generate a constellation that maps the bits on the waveform. And this discover the type of modulation we are using in a very heterogeneous scenario is very important and is one of the goals of this work. As I mentioned, systems are not perfect, they are not ideal, they are imperfect. And receiver side, there will be imperfections on the constellation. Constellations will have noise, will move, will spin, and this will be responsible for errors while detecting the transmitted bit stream on the receiver side. And as we move to the current bands using, for instance, in 5G, to higher bands using 6G, things will become even worse. Okay, so and basically, what are the components that are most responsible for the imperfection? Basically, the up converter, the power amplifier, and also the oscillator, because this is something that is specific for the transmitter side and for the receiver side. So these are the main sources of the impairments, because the remaining tasks are all done in digital world, while this is basically analog. In digital world, things are repeatable, things does not degrade with the time, and this kind of imperfections basically leads to this kind of offsets and errors. That these offsets and errors basically do what I mentioned, that the bits, the signals we are transmitting are not stable, are not well defined. But there are also impairments, effects of the channel. When a signal goes from transmitter side, it can be, for instance, a mobile base station, an access point in our homes or in our universities, or a router to the mobile device, or vice versa. We can have several effects. We can have scattering of the waves. We have multipath, because signals can travel different paths, and we can also have fading. And we can have different signals interfering with each other. This leads to very complex scenarios, because we have impairments on the source, on the transmitter, on the receiver, on the channel. The compensation of these impairments is done using mathematical equations, using analytical methods, but scenarios are becoming more complex. And we need more flexibility, more adaptability, and more intelligence to deal with more challenging 6G scenarios. And in fact, in 6G, it can have such different and very complex communication scenario. We will have different areas with a different range from, for instance, a urban, really small area to a rural, very wide area. We will have different platforms. We have platforms at ground, at the air. We have also low Earth orbit or geostationary satellites. We have an underwater overseas platform. So, and all these kinds of systems and platforms must interact in order to provide a seamless connection to the users of the terminals that are connected to the network. And in such scenario, that are too many sources of information, that are too many transmitters, probably using different standards, is very important to identify sources, the standards, the way systems are communicated. So the increasing number of devices requires a more efficient and agile spectrum access and monitoring. We must know who is transmitting where, because, for instance, it's one of the things that is becoming common is if I want to communicate with you, I can send a beam of a radio frequency beam directly to you and not to the other user. So identify what is in the surroundings, what is transmitting, what bands of what frequency bands are being used, what standards are being used is very important. This is important to basically ensure a reliable transmission, but also, for instance, to identify interference, someone or some device that are not allowed to. So, and this basically the procedure of identifying the who is transmitting, where is transmitting, and characterize the signals is called RF fingerprinting. And in 6G, this operation will become even more important in order to ensure reliability and in particular in crowded spectrum bands. So, and this is a picture that basically shows why fingerprinting is important in more detail. So you'll have very different types of devices using different standards. We have an explosion of connected devices, not only our smartphones, but also IoT devices to support machine-to-machine communications. For autonomous driving, to support ultra-reliable and low-latency communications, and many other types of communication. We have devices that, for some reason, need to communicate but do not be able to communicate. We have some devices that are not allowed and they try to interfere and to present security threats. And we want to also to ensure the efficiency of communication. So that's why all this is leads to the need of RF fingerprinting. One of the steps, not just one, because RF fingerprinting includes many operations, is the identification of modulation. So I mentioned in the beginning what is modulation. It's basically taking bits and generate waveforms. Identify the particular modulation that is being used is a critical aspect. And using traditional systems, when the more conservative environments, we can use analytical methods. But as we move to more dynamic environment, and more important, to very noisy environments, which means that we have degraded signal-to-noise ratio. So the power of the noise is becoming similar to the power of the signal. This type of analytical methods is basically becomes to start. Does not give a good answer to the modulation classification. So that's why more recently methods based on deep learning approach are being used. So basically we take the signal, we apply a CNN network, an algorithm, and then we are able to identify which modulation is being used. However, this resides the problem that motivates our work. Basically, most of data sets are not real data sets, are synthetic, are generated, for instance, in MATLAB or similar. This summarizes basically data sets. I'm running out of time. I have 5 minutes, I know.
No, because we started 2 minutes. So
okay.
Don't worry, I will give you the time.
Okay, so great. So this table basically summarizes the data sets available with different signals. As you can see, these are synthetic. This is over the air, so it's more realistic. But in terms of modulation, in terms of sampling ratio, in terms of some, I did not mention what is rollout, it is explained on the paper. But in terms of the features that we want to change in order to have a realistic data set that we can use to train our network, those data sets is very limited. So we start an effort in our institute in order to generate new data sets that we can basically use to train networks and see what we can achieve. So this is basically what I mentioned. So as a bottom line comment, so no prior studies only varies some parameters that we use in our work in order to use them together or separately to train our network. And why is important to have a rich data set using separate impairments, separate imperfections, or combining imperfections. Because if we need to deploy our models at the network center in the cloud, we have no issue. So there, the power resource, computing resources these are sufficient, there is no issue. The problem is when we want to deploy our algorithms, our networks on edge devices, for instance, on smartphones or on IoT devices. Here, the computing power is much more restricted. So having data sets that you can use to train different networks for different scenarios with different complexities is very important. So that's why we started with this. So we can tailor the size of the net, train it for specific impairments that are especially devoted to a particular scenarios when some impact, some impairments, some imperfections are more relevant than the others. Instead of having one size fits all model that would be huge and will consume too much power at the edge device. So the objective was to create a data set with different features, experimental measure how these parameters influence or affect the identification of the modulation, and also compare the obtained performance with state-of-the-art techniques, mainly based on those synthetic data sets that I mentioned before. So what is the workflow? We basically generate a data set in lab environment, so we use laboratory equipment. Then we train the network, we validate and we test, and in the future we will also deploy the training model on edge devices. Basically, these are the steps. So we generate in the lab, we try different parameters, modulation or oversampling ratios, signal-to-noise ratios. Our target is to make the data set available, and then, as I mentioned, the edge deployment. So these are the parameters we use for now. We vary the sampling rate of the signals with the different signal-to-noise ratios and for different modulations. Moreover, our data set in terms of structure is compliant with Wikisource, which simplifies the analysis. This is just a snapshot of the network we are using. So we are using 5-layer residual CNN, that is described here. Why use CNN? Because they can discriminate features directly from the raw IP samples, or from the signal samples in a simple way. These are some pictures of our laboratory setup. So we generate offline the signal, but then we generate the signal, in fact, with laboratory equipment. Depending on the features we are exploring, we want to extract, we can use a wired connection. So this is set up. Again, in the paper, we have more results, but just to provide a snapshot of the results we obtained. For now, we are just analyzing the effect of oversampling ratio, signal-to-noise ratio, and modulation order. And as you can see, varying of this oversampling ratio, basically it can achieve training faster and better accuracy results than with oversampling ratio, higher sampling ratio. So, in fact, the oversampling ratio is one of the specs that was not explored on the other data sets, and as you can see, it can affect considerably the accuracy. So I just mentioned this. OSCR that is often overlooked can affect significantly the CNN performance. There are trade-offs between the different parameters that needs to be explored in order to achieve the best model that can be deployed on edge scenario, and this is very important, not to have an efficient model. Okay, I already mentioned this, you can skip. Now moving to the ongoing and future work. So we are adding other features, frequencies of sets, frequency errors on transmit on receiver side. We want also to explore the different features of signal, not just modulation. And as a final goal, and I've already mentioned, very important, we want to achieve a low power, efficient, tiny model that can be deployed on the edge. But of course, this cannot be achieved if we train different aspects, different impairments together or separate, and tailor the model to a specific deployment scenario, because it's completely different. Trainer model to be deployed, for instance, on the terminal that is on a plane, for instance, or a model that will be deployed, for instance, in a power plug that is IoT enabled, that is always located in a single location, for instance, in our homes. Okay, thank you for your attention.
Any question? Actually, I have a couple for you.
Okay, great.
So here you said here in this slide and also in this slide, you said that you wanted to perform the training on the edge. I understood right.
Deployment on the edge.
Only the deployment, because the training usually is done in the cloud, because
Sure.
as you say that there are more resources.
Sure.
Okay, so
My intention was to say deploy, because we perform train based on our optimized model, or not optimized data set for that specific scenario, but we deploy the already trained model.
okay, this is okay. And the other question is from here, that the slide that you provide here. So basically, I'm not an expert, so my question can be also misunderstood or whatever. But the point is that as soon as you, in some way, analyze, taking into account the real data, not generated, taking into account the real data, as soon as you have the frequency, the right frequency, and the right signal, basically, maybe you can also have access to the real data that are transmitted in some way. So, and for that reason, I'm just, let's say, a light come to my mind and say, what about the privacy? Because you are, in some way, you are potentially, you can potentially look inside the data of the transmission. Yeah, if you need.
Oh, okay. To be honest, this was the slide more difficult to be that I did, not because of concepts. For me, it makes things simple for a heterogeneous audience. So this is some basic things. But in order to transmit with very simple steps, it was probably the most difficult slide for me to design. Besides, I'm used with that for 20 years. In fact, this is just the physical layer that deals with signal transmission. Before the physical layer, we have other layers that also include encryption, which means that from the application to the physical layer, there are some steps that needs to be performed, including encryption, which needs that this layer already deals with encrypted data. So there is no plain text data in this point.
Okay.
And this solves the privacy issue.
Okay, I understand. Thank you.
All right.
Again, thanks. Thank you for the presentation. So now let's go to the other presenter, which is and go. I can see you. You can hear me?
Yes, I can. You can see my screen.
Hi. Can so I suggest you
Okay.
not yet. I suggest you just to save the bandwidth to switch off the camera and go. Then we can switch on after the presentation. Okay, so just give me a second to okay, can you put in full screen? Go.
I said full screen. Is in full screen.
No, it's not full screen.
And switch off the camera. Switch off the camera just to save.
Okay.
Set full screen. Let's see.
Okay, you can see. Can you see my screen?
No, it's not. At least not from our side.
The screen is present, but it is not full screen.
Not full screen.
Put it in a presentation
Look,
mode, like F5.
I am already in full screen. So
it's not in full screen. Yes, I can see your screen, but it's not full screen.
Not in full screen.
No need to change the setup of your screen. It is the PowerPoint setup.
So, go.
Không được nhỉ?
But I'm not. So this is
you can
of his side.
Can you see
on
my
side.
screen?
Not yet.
On the bottom of the slide, you can see the minus icon.
It's just a matter of press a button. We will guide you. Share the screen.
Okay, now it's full screen.
Now it's full screen. Okay, sorry, some problem.
Sooner or later.
Okay. Can you see my screen, full screen?
Okay, wait a second.
Yeah.
So, okay.
Okay, now.
Okay, now it works. Now it works. Perfect.
Okay,
so,
now. So.
Basically, let me no.
Now, can I start presentation now? Uh,
Yes, please.
ready.
So
Okay.
share again before.
Good afternoon,
No, you exit
everyone.
from the full screen, but doesn't matter. So let me uh, let me introduce you. You are pa, 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 pa.
Can I start now?
This one, this one. So here we have in Go, which will is usually unsupervised learning. So hopefully, okay. So
Okay. What happened?
you can go. The floor is yours. Go, please.
Okay. Sorry, some problem. Good afternoon, everyone.
Perfect.
My name is Ngô Anh Tuấn. I'm here and I'm here on
You can go.
behalf FPT University and Hanoi Railway Signal and Telecom Company. Today I'm present our research type
From our side, yes.
anomaly detection for Vietnam Railway using unsupervised learning.
Can you go and go?
Okay.
Go. You can start.
Let's start. Okay. Today I present our research type.
Can you hear me?
I can hear. What happened?
Muhammad, can you hear me?
Yes, I can hear you very well now. I think,
Guys.
Mr. Tuan, you need to get closer to the mic so we can hear you better, please.
So it seems that the connection is there, but can you hear me?
Can you hear me? Can you hear
I,
me?
I am Muhammad and I can hear all the organizer and Mr. Tuan.
Okay, I'm starting presentation now. Um, Good afternoon, everyone. My name is Ngô Anh Tuấn. I'm here on behalf FPT University and Hanoi Railway Signal and Telecom Company. Today, I'm present our research type anomaly detection for Vietnam Railway using unsupervised learning based on
Muhammad, can you hear me?
data monitoring.
I can hear you, yes, but it seems maybe you have a little bit delay to hear the presenter. The guy with the name Tuan is presenting now, but maybe you have
Can
difficulty.
you hear me?
I can hear you.
My presentation have focused.
Okay. Thank you, Muhammad. Thank you. So suddenly we could
Our presentation have focus section. First, introduction of study, and next is detailed problem and motivation. After that, we will move on methodology, and final is conclusions. These diagrams show infrastructure architecture on a railway level crossing. In diagram, main device is magnetic sensor. Counting the push generates each time chain will actually pass it over the sensor location. And detection device as follows: traffic light, bell, AC and DC supply, and two barriers. PLC is program logic controller. Circuit collect sensor value and device status through indirect interface with the PLC and send data to our data center. To more detail, I prepare video on a railway level crossing, and I will say it. Okay, in next problem and motivation. The current monitoring system mainly rely on human operation. Monitoring multiple intersections at the same time makes them prone to overload. The volume of real-time data from thousands of crossing points is overwhelming, increasing the risk of delays, response, and the possibility of overlooking dangerous and citizens. It's impossible to define all safety related due to over 40 different sensor parameters, creating a vast anomaly space. The data show complex temporal relationships that require synchronization between chain detection and the response safety device. And next, methodology. So first, data generated by level crossing monitoring system is to store error data in our data center, which located at Hanoi Railway Signal and Telecom Company. Each file store once day of operational data from the device at the specific level crossing, and you can see the figure. Now, with raw data, I will explain it. Raw data collected from IoT systems at railway level crossings in Vietnam contain various types of information, primarily distinguished by the command field. When a train passes through a level crossing, a message with command equal on chain are triggered, indicating critical state change within the monitoring system. Each on-chain message is timestamped and saved at a frequency of one message every 5 seconds, and forming continuous sequence of events over time. And after raw data, we have a filter method. Raw data will be filtered to remove unnecessary records and fields. Each train passing through a level crossing will be revisited a data set containing valuable information collected from IoT device over time. The output will be a CSV file. We have a fit. The most important information fields such as magnetic sensor, control signal, barrier status, power supply voltage, and current intensity. After filtering and cleaning, the dataset will consist of multi-subsets. Each subset represents a single instance of train passing through a level crossing. Unique identifies by UUID. To see sample, we have upload to Kaggle. Now we present feature extraction from dataset. Sensor in railway systems typically exhibit direct interaction and interdependencies rather than merely representing independent statistical properties. To effectively exploit these critical characteristics is essential to apply appropriate data transformation techniques. This the technique enables the extraction of meaningful features that clearly represent the complex interactive nature among sensors, while at the same time reducing noise and eliminating redundant factors, selecting and employing suitable data processing methods directly influence the model's uh, ability to detect anomalies, thereby significantly and enhancing the accuracy of anomaly detection models. And with magnetic sensor, an important characteristic of data from magnetic sensors is value gradually increase over time and rapid as the chain passes. Feature extraction with min-max scan for each type of chain with different lengths. The maximum vibration index measure will vary. However, this does not affect the system's abnormality. We use min-max scaling to normalize this feature as follows. Use threshold x normalize with x normalize. Feature extraction with peak difference analysis. Magnetic sensors are deployed in pairs to back up each other in case of malfunctions. And the time interval from initial to measurement to typically constant. We use PDA to extract this feature. And with the timestamp. For example, when the train detects entering the level crossing, magnetic one greater threshold, the time interval from when the barrier close control signal and given until the barrier is completely closed have a major impact on safety. We will analyze and incorporate this time interval delta time into feature vectors. With this information, we can predict when the device is about to fall. Why we use unsupervised learning and what class SVM to build model to perform anomaly detections. We employ unsupervised learning method, selecting the one class SVM model to build the system. visual on-class FVN for anomaly detection in railway system for following reason. The data collected from railway system are mainly normal operating case when anomalies are rare. On-class SCVN is specially designed for this imbalanced data when normal data sample are their majority. On-class SVN can detect nonlinear relationships between features. This is important in this problem because the relationships between parameters such as magnetic sensor delta time and the state of barriers are often nonlinear. Methodology to apply one's class FVM. Implement step first implement step to view model. Split data into chain and test set scan data. Chain model with cross validation. Evaluate model with accuracy, precision, recall, F1 score, RQ, and AUC. Tune hyperparameters. And in this slide, it results of one class FVN with default hyperparameter. In the table, you can see with default parameter model achieves about 82% accuracy. And after turn hyperparameter, model can achieve 96% accuracy. And calculation. Research has successfully developed an anomaly detection subsystem for railway crossings in Vietnam. Applying unsupervised learning on IoT sensor device, the implementation of unsupervised learning not only helps reduce manual classifications efforts, but also enhance detect efficiency based on large-scale dataset. This work established a foundation for future intelligent monitoring system that can be adapted to different operational contexts while maintaining high reliability and performance. Our dataset extracted in CSV format can serve as valuable reference resource for community, supporting more effective research and development of models. Thank you for attention.
Thank you.
Thank you.
Go on.
And
can you hear me?
I can hear. And
Okay. Fantastic. So many thanks for this presentation. It at the beginning was we had some problem, and now the presentation was easily, let's say, understood. So thank you again for this. I'm asking if there is someone from the platea that has a question for Gohan.
Thank you.
Actually, I have a question for you, Gohan. just a quick question for you. So basically, as you pointed out, can you hear me first of all? Yes, I hope. Yes.
Do you have a question?
Yes. So, as you pointed out in the paper, Vietnam has not too much railway crossing. And how you think this is? So, do you think this is a problem for the training of the model?
Mm, can you send question to chat dialogue?
Okay. Yes, I can chat you.
Uh, Ah, in Vietnam railway system have about 10,000 railway level crossing point. About 10,000. To prepare data for to training a model, all data crossing will send to our data center. In data center, I have data, but I has data with text file, and I use file, and I use it to filter and after filter data, we use it to training model. All data store with text file in data center, our data center. Thank you. Sorry, with some problem.
Don't worry. So now is the turn of Mohamed. Can you hear me?
Yes, sir, I can hear you. Can you hear me?
Yes, fantastically. So
Okay.
please
Yes.
share your slide.
All right. Please confirm if everything is clear.
Everything is clear. Just put it in full screen,
Yes.
Mohamed.
All right.
And let me introduce you. First of all, I apologize for this late, but internet connection that was not in charge of us. I really apologize. But now let me present the next speaker, which is Mohamed, that will bring us to the effect of different attention mechanism applied on 3D models in video classification. Mohamed, the floor is yours.
Thank you very much. Again, I am Mohammed Rasras, and on behalf of the co-authors of the work titled Effects of Different Attention Mechanisms Applied on 3D Models in Video Classification, we would like to thank you very much for giving us the opportunity to present our work. To start off with human action recognition, we need to understand how collecting the data from different types of sensors that can help in detecting the activities or the actions of a human action of the human actions, and that can happen based on, for example, sensors that like cameras, RGB cameras, or depth cameras. Human action recognition is used in multiple actions, especially in video surveillance, in healthcare monitoring, in entertainment and sports analytics. The human action recognition has evolved in the last decade from first by the existence of the 2D CNNs that was used for image classification. And here we have the known models such as VG16 and 19, the ResNet, DenseNet, and other models like Inception. Those image classification were then applied to detect how they will work on video in order to detect the human actions. But unfortunately, the 2D CNN lacked the temporal modeling for video data, and this led to a drop in accuracy. So the accuracy that was achieved by images was much higher than compared from the videos. But then scientists start to improve this by adding RNNs or LSTM, which is the long short term memory, to the 2D CNN at the end of it, and in order to mimic of memory sequence of the improve the memory and sequences. They also put two streams paths of the 2D CNN, that one work on RGB data and the other on the optical flow. Finally, they came up with just adding another one dimension to the 2D CNN to form it in 3D CNN, such as C3D and I3D and R2 plus 1D, which we will be focusing on. That adds one extra dimension, how I said, to the original 2D kernels. Surprisingly, all of those work fine, and they improved the accuracy much better than compared to the original 2D CNN. Lately, the transformer, which is based on the self-attention blocks, was introduced, and after its huge progress in natural language processing, and it was applied on computer vision tasks and also has achieved competitive results. In this field of human action recognition, there are, how I said, there are many methodologies were used. Here I focus on only those who focused on the 3D CNNs. And here there are some branches like the regular 3D CNN, which only has a branch, a kernel of 3 by 3 by 3, for instance, or it can be any other equivalent numbers used for the filtering. Then they used inflated 2D models based on this Inception or ResNet 2D. They just added one additional dimension to the kernel, which is here represented as T. And this also has worked very fine. The third approach was by factorizing the 3D. So basically they took the regular 3D filters and then they factorized the kernel, which is one kernel to be 3 by 3 by 3, to be as split it into 2D and 1D. The 2D is for spatial kernel and the 1D for the temporal one. Other work has worked on improving the results by applying two-path solution. One is measuring the fast movement, and the second for the slower motions. There is also a huge benefit in this field for the knowledge distillation, or known as teacher-student, which they used as some model of D3D. They used the optical flow path to teach the model in order to have the best temporal knowledge learning, to improve the learning of the RGB path on the 3D CNN. In our work, we focus on three main 3D CNN models. The first is MC3, stand for Mixed Convolutional 3D CNNs. And the second is R3D, which is based on R2D, or the image classifier ResNet. And the third is R2 plus 1D. The first one, the MC3, has shared the same first two layers as in R3D, means they have 3D convolutions, 3D filters. Then they start to differ after layer 2. That is, in MC3, it starts then to use 2D filters instead of 3D, where R3D continues to have 3D kernels. R2 plus 1D, on the other hand, from the beginning, from first layer, it starts to split the spatial and temporal convolutions into 2D and 1D, how I mentioned earlier. Then for a modification, we added a dropout layer before the final connected layer in order to improve our generalization. Our motivation for this work is to work on these three models, that they have different convolutions or filters, and see how if we restrict the temporal knowledge from the videos passing to the models, how these three models differ based on their different representation of their kernels. So we added different types of attention. After reducing the temporal knowledge, we added different types of attention to this by creating different variants. And we wanted to see how can we increase the spatial, if we increase the spatial data, will it compensate the loss of the temporal one? Means we will increase the resolution after we decrease the temporal and see what will happen. Then we start adding attention types and study the effect of their behavior on these models. Finally, we studied also the behavior of the classes that were affected by such attention. For our work, we took UCF 101 dataset that has a size of 13,320 video clips and has, as its name indicates, 101 action classes. The frame rate on this dataset has 25 and with a resolution 3020 by 240. And it has different categories. So the dataset is categorized as human with object interaction, human to human interaction, body motions, sports, and the music. I have examples of each, also presented in this plot. So apply makeup as a human object, massage and haircut for human-human interaction, body motions, and so on. Now, for our experimental setup, we first, as I mentioned, we started with the temporal handling, that we took sparse sampling of the videos by first taking only 40 frames from videos that have which are longer than 48 frames. Then, out of those 48 frames, we ensure that the video is passing to the model is not less than 32. And finally, we extract 16 frames randomly with different starting point. So the spatial augmentation that we depended on in our experiments, that we resized the shape or the frames to 256 by 256, and then center cropping it to 224 by 224. And that is where we increased the spatial data compared to the original work, which was 112 by 112. We added also the color jittering and horizontal flip. In our testing, we did the same as in training, except it's a common strategy of removing the color jittering and horizontal flip. We also depended on 3 random clips per video for measuring our test results. The model setup that we have, so we started with the backbones. We have the M from modified MC3, MR3D, and MR2 plus 1D, and added to them the dropout layer of 0.4 before the fully connected layer. In total, we have the 3 base models here, and we have 30 variants of, in total, 10 per each with different attention types. The attention types are channel squeeze excitation mechanism, in short SE, that focuses on certain channel and enhances most important feature maps in the convolution and ignores the irrelevant ones. Then we have a spatial attention that represented by the block of convolution block attention module that refines features in both channel and the spatial dimension. The third one is the temporal, which based on the self-attention mechanism. And the fourth is based on the TCN, or the temporal convolutional network, that uses one DCNN to model the long dependencies. For our variants, we have, which I mentioned, 10 per each model. We have two variants that adds spatial and temporal attention before the fully connected layer, specifically before the space-time pooling, as in figure A. In figure B, we added this chosen block. So we kept the temporal here, temporal attention mechanism, but we added after layer 3, 0, 1, 2, 3. After layer 3, we put different types of attention. The one with SE, on channel wise, the CBAM, the temporal attention, and the TCN. And also we tried both the temporal multi-headed and the SE one as well. We also finally in figure C, we tried to see if we added only the temporal attention on all in different locations in the model, like after layer 1 and 2 and 3. For our training methodology, we used the optimizer SGD with a momentum of 0.9. The learning rate was set to 1 to the power minus 3, which reduces every 15 epochs and by a factor of 0.1. For regularization, we had the weight decay set up to 5 multiplied by 10 to the minus 4, and the drop rate was 0.4. We added also early stopping in our training in order to avoid any overfitting and reduce also the computation cost. Here are some results. From now on, you will see the tables that show the results of the 3 models and their variants. I start with the MC3. Here's the original one, our modified original one, and here the remaining variants of it. We see that each one, so even though the original one started with epoch, finished at training at epoch 28, adding more parameters by these attention types, as we can see here, started from 11.5 something, it increased moreover pair depending on the attention. However, the training was faster in some cases, like in the case of of TCN after layer 3, it reduced by 7 epochs less. We also see how the top accuracy improved from 81.2 to reach maximum of 86 when used the attention of all types, all temporal on different locations after layer 1, 2, and 3. We can see also the highest increase per class. So we can see, for instance, the pommel horse class has gained extra 48.57 to its accuracy. The lowest accuracy that we achieved per class, so also some of these has reduced the accuracy on some class labels. For example, the KK King, it reduced to 19.44. Also, in the last column, it shows the least class accuracy achieved by model. So the high jump was the least one with 18.92, and some models like the 3C BAM at the lowest class was cricket bowling with 41.67. Similarly, we have some results for R2 plus 1D. We can see also here the accuracy improved from 85 to reach to 80, almost 89 for the 3 temporal. And similarly, we have noticed that some classes have gained a lot of performance to them, such as the breaststroke for when adding the F spatial or all temporal attentions variants. with an increase of a little bit above 57. Okay, the last variants were regarding the R3D model. It's the same. The top one accuracy was almost 80, and it improved to reach the maximum of 84 when applying the the channel attention after layer 3. Here is a better visualization of the results that we have on each of the three original models and their variants. Here, it shows the model, the original model and its variants, plus the worst 5 actions that were originally misclassified. So we can see that in original model, in the case of MC3, how all those 5 misclassified actions were under 40%, but in some cases, some of those classes reach almost 80 in the case, for instance, of 3 temporal. Similarly, for R2 plus 1, which was even better results. For instance, we take again the breaststroke one that initially was less than 40 and in some cases exceed 90%. And the same case for the R3D variant. We concluded that once we start reducing the temporal knowledge from the videos, we noticed that big difference and big loss of accuracy and performance is achieved by these models. And we also concluded that the increased spatial resolution didn't compensate the lost temporal one. However, the attention mechanisms within these circumstances could add up to 4% extra accuracy to these models. We noticed that the best variant was for 3D temporal on the variant of R2 plus 1D. And we also wanted to mention that in our work, we wanted to study how the behavior per class would occur. In our future work, we would like to focus on applying these attention mechanisms on different methodologies rather than the 3D CNNs, such as the transformer-based and other modalities rather than the RGB one, such as the skeleton, or a hybrid between skeleton and RGB. And also we would like to test our results on larger data sets, such as the kinetics or something. I am very thankful for your listening and your attention, and I'm all ears for your questions, if there is any.
Thank you, Mohammad. Thank you. Can you hear me?
Yes, I can hear you very clearly.
Perfect. Okay. So thank you for this presentation and for the work. Quite impressive. Is there any question from the platea from Mohammad? Actually, I have a question for you, Mohammad.
Yes,
so the point, so you show basically quite different, let's say, models applied to the imaging. Okay. And even in one of your slides, and there is 11 in particular, you say that to prevent overfitting, you perform early stopping and also to reducing the computational cost. As I said at the beginning, these the methods and the technique that you use can be very computing demanding. What about the computing power that you use, the computer architecture that you use for this? And as in the conclusion, you said that you want to perform even more work and even more use more data. How you think to go, I'll say, to go around and for the limitation of the actual computing power that you may have, if any?
Okay, thank you. Thanks for your question. So first of all, I would like to thank also our university for providing us the university grid platform that is a supercomputer that has a Tesla NVIDIA cards, allowing us to run very large models with much less time compared to normal computers. So we tested our models based on the, I believe the model configuration was NVIDIA Tesla HX100 that is used for deep learning. And for the early stopping, we use the early stopping because I don't want redundancy once training the models, especially that I limited the temporal information, and this can cause overfitting of the system. So I used a technique while training to early stop once the model is the loss function is not reducing by a very small value, then the model halt its learning, and then start the testing. Based on the second part of your question that is related to the larger data sets, these are really large data sets that I mentioned. And yes, we are planning to work on this, our university grid, because I believe it's powerful and we can manage the training time. I hope I answered.
Okay. So you are right now you are using supercomputing basically. So at least GPU resources for that.
Yes.
Okay. Thank you, Mohammad.
You're
Appreciate
welcome.
it. Thank you again. And so with Mohammad, we finish this second session of the workshop. Thanks to all of you to be here and to prepare your valuable contribution and to share this information with the other in order to, let's say, improve our own knowledge and get, let's say, following this approach, we can get even more results and obviously communication. Thanks for all of you, and even if it quite late, sorry for the problem that happened, but I close this second AMD session and workshop. Thank you again, and enjoy the rest of the stay here in Turkey.
Thank you very much.
Bye.
Hello, good morning. Do you hear me? Uno. Allora. Ok, va bene. Ciao. Ciao Elena, mi sentite? Mi sentite? Non sento. Non vi sento. Ok. Io no.
Okay, can you hear us?
Ok, perfetto. Sì,
Yeah.
Ok. Mi passo il cavo HDMI. Questo funziona.
No, ma noi la sentivamo, era lei che non sentiva noi.
Ora sento.
Si sente, sì.
Audio e video, giusto?
Can you hear us?
Yes.
Okay.
Thank you.
Yeah.
Perfetto.
Ok. No. Aspetta, che troppo bello. Serenità. Stavo pensando, questo lo vogliamo spostare di qua così evitano di cadere giù. Di tirarlo giù.
Questo. È un bel costituzionale.
Questo qua non possiamo levare dalle bola.
No, questo lo usiamo per
Questo
presentare.
serve per le presentazioni.
Io seguo le presentazioni in piedi e poi perché c'è
Perché le presentazioni qui non le possiamo mettere?
No. Adesso andiamo.
No. Ah, un'altra sede.
Sì. Sopra mi faccio traduttore per fare la sviluppo. Non c'è limitazione. No, è solo il trasformatore che succede solo. Cavolo, che pericoloso.
Quando volete cominciare, signora?
Piuttosto saremo rapidi. Sono tutti amici.
Thank you very much. I'm sorry for the urgency, but
Me?
definitely don't work.
Are you connected? Are you online?
Yeah.
Hello?
I'm not chirping.
Yes, this is for the chair. But she
Are you
can-
connected in this room?
No.
No? Okay.
Let's take this from another one.
I will search some help for you. Okay? Just to
Okay,
have the
okay.
presentation before.
When I make a presentation, I need to connect to get into that Zoom. Just
Okay, otherwise we can use this now.
This one, your presentation should work on this one.
This is another
Another line.
I should mute.
Now, yes, you should.
Okay, so
I think we can start. See, Stefania, can you hear me? Just look
Yes,
at
I'm
me.
here.
Okay, thank you. So I think that we can start. Start. There is a phone over there. We can start and good evening, good afternoon, and I'm pleased to stay here in Istanbul. I'm Elena Cantatore, the chair of this session, and I would like to thank all of you to be part of this workshop. And I want to thank Alberico Sonnessa that is presenting with me this session. And we have some problem with the connection, the sharing activities, but I think that now we have to start. I'm sorry to with Stefania, but I think that I should ask you to stay into the time, please. I know that is not your problem, but we have a lot of problem here. So, okay, I think that we can go.
Okay. So please let me introduce the first speaker, that is my friend Elena, with the presentation entitled "Mapping Natural and Human Activities Induced Hazards, for Water Heritage in Italian Seaports." Please, Elena, the floor is yours.
Thank you, Alberico. So, as Alberico introduced the title, this work is part of the really okay. There is a little bit of delay, so this work is part of the rework project that is funded by the Italian Ministry of Research and University that aims at address risk mitigation and adaptive reuse of all the architecture included or near to the water that we call dam water built heritage, and we refer to the as the water built heritage to all the architectural heritage that are part of of seaport, dockyards, and riverine industrial area. In this work, the presentation present the result of the identification and mapping activities in terms of possible hazard that may affect the water-built heritage within the Italian seaport. Starting from a general overview in terms of previous activities in risk mapping and cultural heritage, most widespread tools in risk mapping for cultural heritage already exist. The first one that I can show to you is Carta del Rischio, which focus exclusively on officially listed heritage and exclude much port heritage that lack of formal protection status. On the other hand, seaports are complex and dynamic environments where architectural, industrial, archaeological, and infrastructural heritage coexist, and where human activities and multiple environmental and natural stressors usually limit their protection and live together. Main activities in identify the hazard risk of water-built heritage in the seaport area tend to prioritize natural phenomena, while the activity-induced one are managed by the minimum requirement determined by the local regulation framework that make this heritage very prone to this attack or threat. So the work moved toward the identification of these three research questions. What are the recurrent hazards, both natural and activity-induced, that affect the Italian seaports? The question two, are the available maps sufficient to systematically identify and map hazard for water heritage in the seaport? And the last, which kind of focus can be done from a national and a local scale analysis to support the widest effect in the protection of water heritage in the Italian seaport. In order to solve these three questions, we start with the previous data available in the project, such as the cataloging activities referred to 63 items sample of seaport, Italian seaport, that are managed by the ADSP, so Autorità di Sistema Portuale, to be matched with the available administrative limit of seaport in Italy, the available free thematic metadata for the natural hazard proneness in Italy, and finally with the overview and the classification of technological hazard as they are classified and collected into the international MDAT database. In that sense, we have structured a method in a three-phase method that systematize and make a collection of data, systematize them, and make some analysis to solve the queries into a GIS-based environment scaled at the national scale. The first phase aimed at the identification of hazard types in the Italian seaport, calibrating the geographical detail and the predominant activities in port environment, take advantage of the available data that I described before. The phase two aim at the selection of relevant seaports in terms of the presence of multiple activities, so the selection of port with multi-activities and numerousness of water-built heritage inside the limits of the seaport. And the phase three is dedicated to the hazard mapping. The hazard mapping that in the scope, in the aim of the project, is calibrated as water-built heritage centered, not at the site scale. In this case, we have to study the interferences and the possible vulnerability of the water-built heritage coherently with the limit, the administrative limit of each seaport, the limit of the area that are present into each seaport, local map of natural hazard that we have collected before, and the location of water-built heritage. In this case, the phase three aim at measure the outcome, so present the outcome just for the Apulian seaport, so just for the southern part of the smaller region. What about the outcome in a national scale, and what about the hazard in terms of natural type? Most of the seaport are featured by a higher level relevance in terms of hydrogeomorphological vulnerability. The geomorphological one are quite lower, while and finally the seismic one is quite distributed. At the same time, we recognize that seismic vulnerability is in a certain sense scattered in all the national landscape. So we have decided to not make in-depth analysis for seismic vulnerability. Following, we decided to understand the okay. We decided to we have to solve the query about the activity induced hazard, and in this case we have highlighted the dominance of the seaport that are featured by the presence of four activities or more than four activities. And we have created a correlation matrix where activity type cataloged into the catalogation process for the seaport and the MDOT type of tweet are merged in order to highlight which kind of hazard type are the most recurrent ones. As the first outcome, the main relevance in terms of activity-induced hazard is the focus on explosion and fire, but also their relation with the transport accident. That is the main activity of the seaport. In this case, we have declined the opportunity to study the industrial production for two reasons. The first one is that the general overview in terms of national regulation determined by the industrial production is very very in-depth structured in terms of regulation and normative. The second one is that the industrial production is quite the very lower representative activities for the entire sample. So we have decided to concentrate the attention to the explosion, fire, and transportation accident, focusing on the accidental hazard. Going beyond and analyze the outcome of the census, so the cataloging activities, we can see how many water-built heritage are excluded from the official list. So we have win in terms of recognizing this kind of heritage, but at the same time, you can see the four seaport that we analyze in the third step of the process of the method. And we start with the activity on the focus with the Apulian case studies, highlighting that more than two-thirds of the 66% of the water built heritage are located in areas that have not destination, have not activities. So we can say that maybe this kind of heritage are excluded, can be excluded by perils in that sense. However, when we decide to apply the evaluation of the effect of an explosion determined by the explosion of a ship during a collision, the result is that most of the cases are located so far from the explosion sources with a main effect with people in terms of distance, while one-third of these water-built heritage are located in the nearest part, so the most are near the explosion area, suffering some disruption effect. So that this is the discussion in terms of, in the case of Taranto. Slowly, but the image appears. In the case of Taranto, we can demonstrate, as we can what we can say, because the point of explosion that is near to the mercantile dock in the case of Taranto affects three of the four water bill heritage. The main five water bill heritage, but the main effect is derived by the national activities and not by the industrial activities that for the regulation are already managed to be far from the cities. This could be also read in terms of, in the case of Brindisi, uh, even if the type of water bill heritage is archaeological one. In this case, even if the distance is just the lower one in terms of peril, in terms of distance, it is interesting to see in the future which kind of activity and reuse we can apply to this kind of heritage, also because we are talking about archaeological area that usually are open to external people, so used by tourists. So we can close in try to solve the three queries. What are the recurrent hazards, both natural and activity-induced, that affect the Italian seaport? We can say that the large-scale analysis has highlighted the relevance of hydrogeomorphological criticalities in the seaport areas. On the other hand, the census of port activities has revealed the high importance of the explosion threat, mainly determined by ship accidents instead of industrial production properly regulated at the national scale. What about the query 2? We can say that the use of national or regional thematic maps of natural hazard is a powerful tool for exploring large territories, aligning with the scale and the level of detail in their processing. However, difference exists in managing natural and activity-induced hazard, highlighting the scarce attention toward the latter at the national scale. What about the query 3 that you will see in a moment? Query 3. The lack of data for more than the 40% of water built heritage in the Italian seaport into the National Geographical Database, such as Carta del Rischio, has demonstrated a clear gap in the available maps, limiting the national coverage of in-depth analysis, as well as in their management in terms of protection. Conversely, the variability of activities and their combination, the seaport, limit the opportunity to manage their effect on water heritage at the national scale, moving them to the local scale, to the local one. Ship accident appears as the only scalable activity-induced hazard for the water heritage seaport, as the most representative in terms of main relationship between the discovered water-built heritage and the prevalent nature of the seaport. At the same time, as demonstrated for the Apulian case studies, the assessment of water heritage vulnerability to explosion cannot be directly linked to the activity of the specific area where the asset is located, but result from the analysis of the activity of the port infrastructure as a whole. Thank you for the attention, and I think that maybe some questions could be moved at the end of the session.
Okay.
Okay.
Thank you very much, Elena, for your presentation. So,
Thank you for the attention. So I think that we have to move to the second presentation. I have to present Alberico Sonnessa, that is now he will present this work that has the title GNSS PWV, an intense rainfalls event, an analysis of 2 years of observation acquired by the SNP course on the Bari area, Italy. So
thank you very much, Elena. Just But where is the presentation? Is on this one?
No, the presentation is here. You have to share.
Okay. Sorry, there is some delay. Okay, we are waiting for the presentation to upload. Sorry for the delay. We are almost ready. I hope so.
It is going.
Okay, more or less.
Okay. In alto, slideshow, se vi ricordo presentazione.
Dov'è?
In alto, a sinistra vedete le schede, slideshow. Yes. Everybody lascia stop in first. Ma adesso è molto difficile.
We are waiting for the software to upload the presentation. Sorry, it's a bit slow.
Okay.
Okay, I hope you can see my screen. I'm not sure about that, but okay, let's start our presentation. So thank you, Elena, for the introduction. I'm Berico Sonnessa from the Polytechnic University of Bari. Let me check, as usual, let me thank my co-author Eufemia Tarantino and Alessandra Mascitelli. And let's start from some definition. What is a built environment? A built environment is a network of streets, buildings, infrastructure, and of course, the people who lives in this space as use this infrastructure, you know. But the built environment, has a big problem. We have a big problem. This problem is, let's say, climate change, of course, because we have starting from the 1850s, so from the pre-industrial era, we had a constant increase of the average temperature, and we can see it in particular mode from the 80s, as shown in this graph. And climate change and heavy anthropogenic pressure suffered by large portion of our countries are having a growing impact on the built environment in terms of landslide, in terms of earthquakes, and in terms of heavy rainfalls and floods. But let's focus on the last. The rapid onset disaster category. Okay, so disaster that happens in a very, very short time, let's say. Can geomatics play a role in countering these events, in countering heavy rainfalls event? The answer is, of course, yes, geomatics can play a relevant role in this field, especially GNSS systems, okay? Everybody knows that the GNSS systems use mainly for positioning, but and navigation, of course. But in this case, if we refer to continuously operating reference stations that are particular GNSS station they are placed in a safe place, on a safe mounting structure, so they are steady, they doesn't move, we can use, of course, GNSS permanent network to counter this kind of events. Why? First of all, let me introduce our station, the SNIC station. We have in the Polytechnic of Bari one reference station that is called SNIC, is able to track to track for satellite systems that are GPS, GLONASS, Beidou, and Galileo. So the American, the USA one, the Russian one, the Chinese one, and also the European constellation is included in the European Permanent Network. That is the network of reference station used to build the European reference frame, the EUREF reference frame, and which part of the signal we are going to exploit to counter this event. So we know that above our heads we have more or less 1,000 meters of atmosphere. The last part is the troposphere, and the troposphere contains water. Okay, contains something that is called precipitable water vapor, PVV. Water that is capable to turn into rain, let's say. Okay, so we can monitor with the GNSS this delay of the signal from the GNSS from the satellite to the receiver due to the precipitable water vapor, the PVV. We can obtain this data, and what we want to do is to relate GNSS PVV to water, to precipitation in the Apulia region, in particular in the area of Bari, in the municipality of Bari. We want to compare these two trends, GNSS PWV with the precipitation. Let me introduce our case study, that is the area of Bari, as I said. We have our station, that is the triangle in red here. And near our station, we have got 3 rain gauges. Bari Campus Gauges is 40 meters far from our station, while the other 2, Bari Osservatorio and Bari Idrografico, are more or less 1.5 kilometers far from our station. Okay. Every rain gauge acquired data every 5 minutes. And so we computed the GNSS PWV every 5 minutes, starting from a raw data of acquired every 1 second. Oh, I'm very happy of this. We can see this image. Okay. Okay, but first of all, what we did was the identification of rain events. And what is a rain event? Rain events is an event preceded and followed by 6 hours of a dry period, characterized by a precipitation, average precipitation, cumulative precipitation of 1 millimeter equal to or greater than 1 millimeter, and at least 1 measurements of rainate greater than 0.5 millimeter. Okay. Sorry for the table. I don't know why we can see the table on the right side, but in this study, after the identification, we classified our rain events by focusing on heavy rain, very heavy rain, and cloud burst. Very heavy rain, all these groups, heavy rain, very heavy rain, are characterized by an average intensity of rain measured in millimeter per hour, greater than 6 millimeter per hour. Okay, so what we found was this kind of correlation. In red, you can see the PWV measured by GNSS, and in blue, of course, you can see precipitation. And what we can see is that before the precipitation, we have an increase of of PWV in the air, in the troposphere, then the PWV starts decreasing and it starts raining. Okay, so we have two peaks. The first peak is the PWV peak, and another peak in terms of rain intensity. Okay, so this correlation is very clear. What we found was one event, the heavy rain event, so with an average intensity between 10 millimeters, 6 millimeters, and 10 millimeters. We detected six very heavy rain events. So the intensity was between 10 millimeters and 30 millimeters. And we found also two events, two cloudburst events were characterized by an intensity of greater than 30 millimeters. Okay, so what we want to do, what we want to do in this study is can we correlate directly this to the peak, the PWV peak with the intensity peak? In other words, when the PWV reach a certain value, it rains, always rain, or this correlation is not so clear. So what we did was computing a median of all the PVV events of PVV peak we detected, and we used this median in, let's say, as a threshold to foresee the events, let's say. Using this criteria, so using this value of PWV, what we found that we found that we found 24 events, 24 days where the threshold was reached or exceeded, and we can see in this table 24 events were detected. Six events, corresponds to intense events. 3 events that we detected using the rain gauge were not detected using this criteria, while 7 events were detected but are not intense event, and we detected also using this criteria, this threshold, 11 events, but these are not rain events, are dry events. Okay, so using this criteria, we have some correspondence. The 67% of heavy rainfall events were successfully identified by this method. 33% of intense events were not identified, and when detected any events, let's say the time gap between the PWV peak and the intensity peak range from 25 minutes to 11 and 50 minutes. Okay, so we have still strong limitation if you want to use the PWV peak for, let's say, for nowcasting. Okay, why we have this limitation in this particular case? Because probably because the time series is very short. We have just 2 years of measurements, so we will need a longer time series. Of course, we will go on with the study, try to analyze a longer series, a long genesis series. And the approach, of course, is very simplified. We should include other parameters, not only the PWV map, but probably also temperature and pressure. Okay. So in the future developments, we would like to integrate the data from core station in the Apulia region. So we will analyze also other core station and the corresponding rain gauges, of course. We will incorporate additional performance metrics such as lead time distribution, false alarm rates, and so on. And we will combine PWV variability with other parameters, as I said before, such as pressure and temperature. Thank you very much for your attention. can move to the next presentation. So let me unshare my screen.
Stefania, are you ready?
Yes, I'm
Ready,
here.
but-
I'm ready.
Okay.
Sorry,
Okay.
give me a second.
Okay. Okay. A few seconds. I'm sharing the screen. Okay. Do you see my screen?
No, not yet.
Show the presentation.
Let me know.
We can see your screen, but it is the live from our room, so you have to share your presentation.
Yeah.
Okay.
Okay.
Thank you, Stefania, for your participation. And Stefania, we present the two works. The first is the interlink between urban growth and flooding, lessons from the city of Bari. And if you want, you can start. Otherwise, I can also present the second one. But if you want, you can start.
Okay. Thank you for introducing me. Sorry, but I am okay. Okay. Thank you. My name is Tania Santoro, and I'm a researcher at the National Research Council of Italy. And today I will present this work that is a part of a project carried out in collaboration with two research teams from the University Polytechnic of Bari, and specifically the Department of Urban Planning and the Department of Hydraulic Engineering. Oops, sorry. Okay. This work arises from scientific findings in the field of integrated flood risk management, and specifically to manage flood risk in urban environments, analytic approach is essential. And urban transformation, human activities, and also the effect of climate change have altered the way of hydrological phenomena. But so, what does it mean in practice? It means that land consumption combined with the rapid infrastructure development has disrupted the natural processes of hydraulic conformation, such as infiltration, surface runoff, aquifer recharge, and so increasing hydraulic risk. As a result, we now face a paradox because areas once considered safe from hydrological hazard are now exposed to flash flood. Flash flood is characterized by rapid onset and limited warning time, so causing significant damages to infrastructure and also daily life. So this situation calls for a paradigm shift in flood mitigation strategies because the traditional measures focused only on the river flooding are not longer enough. So it is now crucial to integrate new data, new knowledge, relating also to the emerging risk areas, which are not captured by conventional hydrological mapping that we know as a flood risk hazard map. And so, in the urban context, different types of flood can coexist, but mitigation measures are only designed to deal with fluvial flood. So the event has changed. Also, the urban environment has changed, and so also an approach to mitigate risk, flood risk, is needed to be changed. In this context, the aim of this study is to investigate the relationship between urban growth and hydraulic network through an integrated methodological approach that combining a geographic information system and also risk perception survey from local communities. And the combination of the city's evolution, the relationship within the stream network with the community perception allow us to know and to highlight new risky places, starting from also the community perception. This presentation focuses on a specific phase of a broader study, and specifically the steps highlighted in yellow. And so I will share the results from the analysis of a survey of citizens related to flood risk perception and also urban development. And the goal so is to understand the link between urban expansion, changes to hydraulic network, and also the location perceived by citizens. The historical evolution of the city was reconstructed through the analysis of a historical map, which were processed within GIS environment. And these special layers then overlaid with the hydrographic network for special correlation and analysis. And on the other hand, to collect data on the perceived flood-prone areas, a survey was distributed to the local residents, and then open-ended responses were analyzed using knowledge discovery in database technique. The methodology was applied to the city of Bari. Bari is located in the southern Italy along the Adriatic coast. As seen in the map, Bari is crossed by several ephemeral watercourses that we call the Lame, and this is our channel that remained dry for most of the year and activated during really heavy rainfall. So the area has experienced uncontrolled development in flood-prone area, leading so to the organization of these watercourses, as well as the establishment of agricultural crop, infrastructure facilities with their bed and so on. And over the year, Bari has experienced several damages during different weather events. As we can see, we had an event beginning of 19th century to 2005. Following these events, different mitigation measures were introduced. So this include both gray infrastructures, like a diversion channel, and green solution, like upstream afforestation that we call the Mercadante forest. However, most of this kind of intervention were designed to address fluvial flooding and not urban or pluvial flood risk. So, in terms of results, what we have learned from this kind of analysis, from an historical perspective, Bari's the urbanization of the city can be divided into four main phases. The first one is the city was confined to the historic center near to the coast, and it's as a part of red, brown in the figure. Then the second period between 1905 to 1926, in this period, three major floods caused excessive damages, and so prompting the building of hydraulic protection infrastructures. Then, post 1927, economic growth and improved safety led to expansion beyond the old city, and so we can see also the red part and the orange part in the map. And, the last period is related to 2005, and in this case, the urbanization reached also peripheral zone, and the banks of the river network dramatically reshaping the city, as we can see better in these pics. For example, this is a clear example of uncontrolled expansion of the building, and the buildings are close to the water courses downstreams, and inside going further upstream. This is a ephemeral water courses that we call the Lama Giotta. Moreover, another example could be this yellow area in the maps that represent a shopping center built near the diversion channel. And this is an example of how risk-prone areas have become cities of intense urban activities. From the point of view of perceived landmark at risk, analysis of the survey data reveals that more than half of respondents identify high-risk area far from the ephemeral watercourses, and many pointed to underpasses as the most planned area location, suggesting that urban runoff is the main concern. Additionally, while urban dynamics have so to have effect of a mitigation measure, because, for example, also the Mercadante forest now acts as an effective retention basin, so preventing accumulation of downstream water courses. So, in conclusion, the city expanded without considering the hydromorphological network. And moreover, ephemeral water courses and network were urbanized and converted for agriculture, infrastructures, and so disrupting the natural hydrological balance. While mitigation efforts have reduced vulnerability related to the flood risk, on the other hand, the climate change effect and also urbanization continue to generate new risk area. These areas are often perceived by citizens, but is not mapped as a conventional tools as flood risk hazard map. So what we have to do as a researchers is to support the hydraulic protection with also a good urban planning, and moreover to consider social aspect in order to involve the citizen in a process to mitigate flash flood. Obviously, this opens up many further line of research, some of which I will explore also in the next presentation. Thank you.
Thank you very much, Stefania. Can you hear us?
Yeah.
Okay. So, unfortunately, we didn't see anything in which
my God.
Okay, don't worry. The presentation was still on the first slide, but don't worry. Let's move to the next presentation. But okay, just check if everything works well. So please share your screen, and first let's check if everything works.
Do you see my presentation?
You should share not only the presentation, but the entire screen. You have the third option when you.
I'm doing.
Okay.
Yeah.
Okay. So now.
No.
Open your presentation.
My presentation is open.
Okay, we can see it.
Try to go on.
And to activate the presentation mode, and then to go on.
Do you see my presentation now?
Yes. Okay.
Try to change the slide. Move to the next slide, please.
Yeah. Maybe it's a.
Okay, there's a bit of delay. Okay, it works.
It's working. Okay.
So if you want, you can start. Thank you very much.
Okay. Okay, this is the this work. It has been built starting from the previous work presented. the title is a deeper look into flood risk in the city of Bari. And the motivation to investigate urban flood risk arises from the awareness developed within our research team, but also widely supported by scientific literature. And that's that pluvial floods are becoming increasingly frequent. So this trend is mainly driven by land use change and the effect also of climate change. Such events often take the form of intense, short duration rainfall and making their management very, very complex. So in many urban contexts, including also the city of Bari, there is our case study, multiple types of flooding coexist, each caused by different factors. In addition, so to flash flood and so pluvial flood can coexist also fluvial flooding. So of course, when a river overflow due to the heavy rainfall, coastal flooding, of course, when storm surges and strong winds push seawater inland, and this overlap of this kind of hazard can complicate urban flood risk management, so requiring an integrated planning and infrastructure that can deal with this kind of multiple risk. To do this, given this complexity, also the flood directive requires that member states to adopt an integrative and preventive approach to flood risk management. It's not mandatory, it's just a suggestion from flood directive. However, in the guide, the first operational phase defined by the directive is the preliminary flood risk assessment, and aimed at identifying area potentially at flood risk through the analysis of historical, geographical, climatic, socio-economic, and so on kind of data. So this preliminary assessment are not only important for identifying local vulnerabilities, but also form the basis for developing the effective risk management strategies. This kind of approach can guide the urban planning decision and help also to prioritize investment in the phase of prevention and adaptation measures. In this context, the present study have conducted a preliminary analysis of flood-related phenomena with the following objective, with the following goal. The first one is related to create a systematic review of historical flood events. Then an assessment also of precipitation trend in order to also combine with the historical data set, and then an evaluation of public risk perception compared against recording events to identify discrepancies between perceived risk and real risk. So the adopted methodology is a part, as I already told you, of a broader methodology, and so also I'm going to show the line highlighted in yellow. Also, in this case, this work have been applied to the city of Bari. As I already told you, the Bari is crossed by several ephemeral water courses, and different events occurred during the time. To address the first kind of goal, what it has been done. We investigated two types of source, specifically from one local newspaper and through a website. Then, in parallel, days with extreme hourly rainfall were identified using the Italian hydrological yearbook for the Puglia region, and the aim was to verify whether the recorded surface impact were actually caused by significant precipitation events. And moreover, as I already told you, an online survey was conducted asking citizens to identify location they perceived at flood risk. These results were then cross-referenced with the reported events in news sources to assess their consistency. What are the main results from the goal one? The analysis led to a creation of a database of over 18 flood events between the period from 2015 and 2020. Underpasses emerged as a particularly affected hotspot, frequently affected by pluvial flooding. And while some critical points have disappeared over time due to the sewer network upgraded and over also new affected area emerged. Moreover, from the point of view of collecting databases related to the precipitation trend, we can say that short duration rainfall events tend to occur from late summer to early autumn, and longer events are more frequent in winter. And what we have learned is that these intense and short events are often responsible for pluvial flooding, so for flash flood, as confirmed also by comparing with the results from the journalistic reports. From the survey, we have learned that underpasses are the main concern in the city. However, the presence of episodic stream, as I already told in the previous presentation, is the perception of ephemeral water courses is very low among the different group of citizens involved. Just to conclude, to discuss and conclusion this work in this context of increasing exposure to flood risk and in line also with the suggestion of a flood directive, this study sought to gain a deeper understanding of the complex hydrological dynamics in the city. Historical analysis and comparison with the extreme events revealed that the most significant impact tend to result from flash flood, and often triggered by short and intense rainfall, of course, that we know as flash flood. These events are difficult to and hard to manage with traditional hydraulic protection system, and so requiring an integrated approach to take into account not only the physical elements but only the perception of people and how people perceive safety area in the city. So also investigating public risk perception and identify vulnerable areas by residents provide valuable insight to complement technical knowledge. This integration enhances both urban planning and emergency response strategies is critical in time where climate change and also urbanization grow. And so an effective urban flood management must therefore consider also other kind of elements, such as a historical flood event, precipitation trend, and also how people perceive risk. And furthermore, the analysis from the newspaper also allowed us to capture information about hazardous behavior. So it's important also to understand how people perceive risk and react during a different risk scenario. And currently we are working also in this way, and I hope that I could show the result for the next year. At the moment, that's it from my side. Thank you very much.
Oh, Thank you, Stefania. Can you hear me?
Yeah.
Okay,
And you see
perfect.
my presentation, right? Yes.
Okay, yes, now is
Okay.
all right. Thank you for your interesting presentation, but I think that now we have to move and to take the floor to our last presenter that discuss the presentation have the title Simulation Model of Evacuation Behavior During Post-Earthquake Fires, Incorporating Evacuation-Related Information Acquisition. He is Dr. Toshiro Razaki.
Yes, thank you for the introduction. But I need to move here.
Yes, you can.
Yes. But my screen is not up here. Right. Which is the main computer? I just
Yes.
choose.
So you use this microphone, so you
Yes.
should mute your.
Yeah, sure. I'm already muted.
Okay, perfect.
But how to
Sure. Yes.
share the screen here?
Yeah.
Share.
Okay.
Start. Started. Okay. No, doesn't work.
Doesn't work.
The same situation with
Yes.
Stefan.
Yes. So go back to the
Yeah.
Jitsi room.
Mhm.
Okay.
Stop and
Deselect, yes. The sharing mode. No. May I? Okay. Now.
the same
Yeah.
field.
Yeah.
Right?
We're seeing also the
No.
notes.
That's why I don't use this one. But that's okay. I don't understand why share the screen. Share. Okay, share screen now.
Yes, now it's sharing the
Mhm.
presentation. Okay.
And the presentation.
Okay.
Start.
Start.
Here start, but not here.
It's a bit delayed.
Okay.
No, it's a bit delayed. No, it is not going forward. Okay, can you hear us? Can you see the presentation?
Stefania. Oh, hello, Stefania.
Yeah.
Okay. Thank you. Thank you for your response. I'll stop. Okay. Yeah, okay. Simultaneous.
Okay.
Yeah. Okay. So, thank you for your effort. I guess that's so. Good afternoon. I'm very pleased to be here. And this study was conducted in the collaboration with my student, Toko Smegi. And I've been very pleased here. So let me, this is the outline of my talk today. And let me begin with the background to this study. As you may know, the Tokyo is expected to be struck by a major earthquake with a very high probability in the near future. And there are still existing many densely built up wooden houses areas. So we have learned many important lessons from the past disasters. Fire spreading is one of the most serious issues, and many streets are blocked by the collapsed buildings, and the evacuation behavior and the emergency response activities were severely hindered. So given this background, we have been constructing the integrated simulation systems using the detailed GIS databases and building collapse and street blockage and fire spreads are estimated. On the other hand, we constructed the database of the spatial temporal distribution of people, which include detailed personal attributes. And returning home behavior and evacuation behavior and fighting and resource rescue activities are described. All the models shown here are integrated and the simulations are performed by changing the time, the day of the week, the season, earthquake intensity, and so on. So let me quickly illustrate the property damage here. This is an area, typically wooden, densely built up residential area in Tokyo. So completely destroyed buildings are estimated using the fragility curves, differing according to the building age and the structure type. Spatial distribution of rubble is estimated and followed by the street blockages, which are estimated using the street-wise and rubble outflow. So fire outbreak varies according to the building type, season, time of the day, seismic acceleration. So fire spread is estimated using the earthquake acceleration distance between buildings and wind speed, wind direction, building structure, and so forth. So using the demographic databases and the property damage model, we have been performing the evacuation simulations. So this is an example of wide area evacuation simulations. So blue dots indicate the people in evacuation, and the oranges are people with difficulty in evacuation. So due to the collapsed buildings and the street blockages. So, however, many existing models makes uncertain or unrealistic assumptions about evacuation behavior, such as immediate evacuation or shortest route evacuation. Then our aim in this study is to improve the evacuation behavior model. Also, we explore the effectiveness of evacuation strategies and evaluate the impact of influencers who influences the other evacuees. So next, let's move on to the sub-models we have developed. In the previous proposed models, people start evacuate immediately after the event. So to address this shortfall, we newly developed an evacuation probability model first. So first, we define the strength of intention to evacuate, which depends on the distance from the fire. To consider the psychological elements, the evacuation urgency is defined as a variable representing the degree to which the evacuees feels need to evacuate. and then described as a polynomial function of these three factors. And finally, we describe the evacuation probability by this equation. So to estimate the parameters of each model, we conducted questionnaire survey about evacuation start timing. Moreover, so more specifically, we asked their responses by showing the combination of percentage of evacuating neighborhood and disaster information. So we estimated the model using the answers by respondents and applied the model to the data taken in the past disasters, three big disasters here shown here. So the fitness of the model is quite good for all disasters. So we can find some characteristics from the estimated model. When the 80% of neighbors evacuate, even if the fire is far away, the evacuation probability is very high. So everybody starts to move. So looking at the result of women, they start evacuating even when the fire is far away and more influenced by the disaster information than men. To address this uncertain assumption, unrealistic assumption, we incorporate the route choice model, which was conducted in our previous research. So this model describes the route choice probability with considering the distance to the evacuation area, the number of turns, and the street-wise. To address this limitation, so we incorporate the following behavior model in which evacuees change their behaviors according to the information obtained from the other evacuees. So in the model, so evacuees obtain the location information of the evacuation area from others. If the evacuee came across a person who are familiar with the localities, then they obtain the information and follow this person. This is the following behavior. And also the evacuees obtain the disaster information on fire and street blockages. For example, let's assume that this person thinks that there is no fire, never seen before. However, after communicating with the others, the number of sources of information about the fire exists. Then this person judges there is a fire. So decision will be changed. So finally, we incorporate the walking speed model. We employ the walking speed model in which the values change across the sex and age group and the degree of the congestion. So let's move on to the scenario for simulation analysis. First, I'll briefly talk about the two types of evacuation shelters. Temporary meeting points provide a sufficient space to ensure the safety of the people gathered. Evacuation areas are designed to protect evacuees from the spread of fire. These are examples. And there are also two types of evacuation strategies. In two-step evacuation, people evacuate to their closest temporary meeting point and move to the evacuation area when fire is approaching to them. This strategy is intended to avoid congestion around the evacuation areas and actually implemented by the Tokyo Metropolitan Government and the local authorities. In the direct evacuation, people evacuate directly to the evacuation area. These differences. So scenario setting. So scenario A, we assume the people will take two-step evacuation, okay? And scenario B, we assume the direct evacuation. These are the A1, 2, 3 is a variant of the scenario A. A1 is different in the fire approaching distance for second evacuation. In scenario A2 and 3, people evacuate directly to evacuation area if the evacuation area is located closer than the temporary meeting point. So also we set up a scenario in which the influencer's behavior is different in evacuation starting time and evacuation route. We assume here 1% of evacuees are influencers. So analysis and the results. This is slide shows the simulation conditions and the study areas. All of them are designated as a high fire risk zone in Tokyo. So first, let's compare the result of two-step evacuation and direct evacuation first. We can see that evacuation routes were almost the same. However, in case of two-step evacuation, the number of people near the temporary meeting points were extremely high. Also, the sum situation of cases, simulation cases show that a significant increase in the casualties in scenario A compared to the scenario B, like this. So this figure illustrates the change in average and maximum casualties over the first 24 hours. So large casualties around 6 hours after the event in the scenario A. This highlights that second evacuation could result in significant damage, despite the two-step evacuation being designed to enhance safety. Scenario A3 shows the greatest reduction in casualties. This suggests that we need to switch to direct evacuation based on the real-time information about fire spreading. So it's simply because second evacuation were sometimes hindered by fire-related street blockages. So we can say that in high-risk area, direct evacuation strategies should be recommended. So the evacuation start timing is brought forward because they followed influencers who evacuate immediately. This shows that earliest possible evacuation behavior is vital to disaster mitigation. So we analyze the impact of all-knowing and all-powerful influencers. So he or she knows the where location of the fire or location of the street blockage and so far. So we can see here indirectly effects by the influencers. The number of casualties decreases because the evacuees for the influencers could move along the safer route. So this is a main street in the area, blue line, the number of people passing along the main street increases if the influencers choose a wider and safer streets. So these are quick summary and conclusion remarks. Maybe due to the limitation of time, I'll skip over the just quick futures work. So we need to work on the validating the model and the model parameters employed in this study and improve the model by describing the evacuees who evacuate in group, in family so far, and provide insights on how many influencers will need to be provided with correct disaster information and develop information systems capable for providing accurate real-time updates on the necessary information. So that's it. Thank you for your attention.
Thank you very much. So, just a curiosity on the last part, the last slide. Sorry.
The future work?
Yes.
Yeah.
What do you mean for developing information systems? Something based on apps or something like that?
Yeah.
Okay.
So as I shown in my presentation, the correct information. So influencer who has the correct information where they located, the location of the fire or location of the street blockage, then so other people follow the clever all-knowing influencer, then number of casualties decrease. Then that means so correct information is necessary for evacuation, but not for everybody, but only the key person need the correct information, real-time information.
You need to identify before this key person.
Yes, yes, yeah. One person from the 100 or 1,000, it doesn't matter. Maybe the key person is necessary, and he or she should have the correct real-time information.
Okay, thank you very much.
Thank you.
So, Stefano, thank you for attending.
Yes. Somewhat wrong.
So 6 person, 6 attendants, and 1 cat.
Market. Was too boring, so we can't start. I want to work. I want to go outside.
So I think that we can close the session. I want to thank all the people that participate to our workshop. Thank you, Stefania, also for your double presentation.
Thank you.
I'm seeing you in the other screen, so sorry if you. Ah, la mia, era ragione, scusate. What else? Michael Chair.
Okay, we hope to see you again next year, probably in presence. It will be better in presence, but again, thank you very much for your presentation, for attending this session, and thank you again. Goodbye. Thank you very much.
Thank you, guys. It was a pleasure. I'll see you soon in Bali, maybe first.
And of course, we apologize for all the inconvenience and all the issues. Thank you very much.
Thank you.
Bye.
Have a good day.